All right, I'm going to give a little demonstration of how to use Pangeo on CHS. I first go to Amazon Workspaces, and I have a Firefox browser here running. I'm going to go to full screen here to maximize my real estate. And so I've got this, I've got a notebook here that's not running. I'm going to give a little more real estate again by closing down this left-hand bar. Okay, so I'm going to import some packages here. You can see the little star changes from star to 1. It means I've run the cell. And now I'm going to go down and create my cluster, a Kubernetes cluster. I'm going to ask for 20 workers. And there they come on. And so now I'm going to go ahead and open up my data from a bucket. It takes a few minutes, 2 seconds to read the data. It's just reading the metadata. And I can take a look at that data, and I can see that it's 720 time steps and 9 million nodes. And it has some additional attributes like the units of meters. I can see how big this data set is. It's 53 gigabytes. And now, so if here's the computationally challenging computation. I want to compute the maximum water level over that entire field over the time dimension. And if I go ahead and execute this, you see I haven't done anything special in terms of parallelization or anything. But if I go ahead and run this cell, it'll start using that cluster automatically that I created up above. And after the scheduler gets done figuring out, how to partition the jobs, it starts sending these jobs off to this, off to the cluster, reading the chunks of data, computing the maximum of each chunk, and then combining that together to actually process all that 53 gigabytes of data. So we stored the data in about 100 megabyte chunks, which is sort of optimal for storing on the cloud. The same workflow, though, also works on if you have these chunks locally. So we're using a format called ZAR, which is going to be one of the next backends for NetCDF. And it's very efficient at storing each compressed chunk in a separate object, actually a separate item in the bucket. So it's a separate object. Each processor can just go read that object, pull it back, uncompress the data, compute the maximum. And so within the period of about 1 minute, we can see that it's read all of the 60 gigabytes of data. And if we go ahead and execute these next cells here, actually, let's just go ahead and execute the whole notebook. We can go back and talk about what it's doing. So here, after we've computed that mean, we're basically just loading in these holoviz tools. And these holoviz tools will actually basically render on the back end. I say rasterize equals true, and then deliver back at a certain number of pixels that I specify. So here's 600 by 400. So here's the result of that maximum water level calculation. And we can use these interactive tools that have been created in Python, but actually are just doing JavaScript to go in and actually see what's going on in the Gulf of Mexico. And you can see when I zoom in, it rescales the plot and gives us a new plot at that increased resolution, so we can keep going in to the full resolution of this 9 million node grid. So this is a pretty amazing, I don't know. To me, this is pretty incredible. We weren't able to even visualize this in the browser before. And if we go down here, we can extract just a single lat long location, of course, and look at a time series, which also just takes a couple of seconds to load.